Hello friends, we are continuing with the series of videos on PC and cuda. So there were 19 videos before this. So the 20th video is going to be on the AI program for weather forecasting. This is the first time we are doing AI program which is run on an HPC for weather forecasting. This is comparatively a smaller problem for an HPC machine. Still we wanted to explore and see how it works. Now the details of the program are like this. The program uses get command. To get command is to get HTTP get from openweathermap.org, where they are posting the weather data actually. So the updated weather data from openweathermap.org, they record information about weather, and that is being read by this file and writes into a CSV file. It's a simple CSV file, comma separated by values file, and then program then reads the contents of the CSV file and uses it to train AI model. Now when it is written into a CSV file, the latest 10 data are being used to train the data, the model, using LSTM technique. And LSTM is a forecasting algorithm, so which is very useful to predict. And we can adjust the number of epochs, the number of times you train for a better accuracy if you want. And once training is done, the model is ready for forecasting. Now the program continues forecasting every second and also collects new data for further prediction. The program creates batches of epochs and sends them to the GPU for computing. So it is being done online. So automation learning this is, and it is processed in GPU. We have used PyTorch for GPU computing, which is a Python library with CUDA environments. The program looks like that. See that we need to import certain libraries like CSV, pandas, torch, etc., etc. Then we also have libraries for plotting. So the API where we are reading the data is openweathermap.org. So you are just reading the data. They have informations like temperature, feels like temperature, temperature minimum, temperature maximum, pressure, humidity, maybe much more, but we are interested in these data. Now write to CSV file is a function which writes all this data which is coming from there and writes into a file. Now the data collect data function is to continuously fetch and store the weather data. Then for LSTM we have LSTM model definitions are here. In any LSTM means you have input layer, hidden layer, output layer, etc. Number of neurons, etc. can be defined here. This is a neural network model through which it is predicting. So now the function to load and pre-process data is called load underscore data. That is what is pre-processing the data. That means you need only 10 data to be fed in. So and some filtering, etc. whatever is required, cleaning the data we call it, and it's done through this. Then training is done, use train model, then some plotting also. The entire program looks like this. Collect the data, then you put a window or sequence length of 10 that is being fed into the load data, and after that is gone through the LSTM layer to train and come out with a model, and model is brought out here. And you have to simply, with respect to the model, you have to know forecast. So this is the entire program. You can see that the same program which we discussed. The output, see that when you run the program, Python 3 weather forecast model.c. These are the collected data like minimum temperature, maximum temperature, feels like temperature, air pressure, etc., humidity, etc. So now the forecasted values are here according to certain fields, like the similar fields like temperature, feels like temperature. This right now temperature is 33 predicted, and is predicting the next values according to the timestamp. If you are taking every 1 minute data here, it will predict every 1 minute next data. The timestamp predicted, the timestamp at which the data is collected is equal to the timestamp at which it is being predicted, because it is predicting next 10 points. Each point is a timestamp. Now, like this is the feels like temperature. So this is the temperature minimum, this is the temperature maximum, and this is the pressure, humidity, etc. So it's able to predict continuously, automatically. Now we go into the demonstration of this. So we are connected to the HPC machine right now. Now it's again, this is a Windows machine where we are putting, when we connected to that machine, and then we run a script called start, and after that we are the script, what this script contains. If you want to see, this is like this. You are allocating a CPU minus srun minus n. 1 means 1 CPU and 2 GPUs, and that's all. You come out of this and run the Python program now. So in order to do that, module load mini conda, that is what is required. So this has been discussed in the last video. Then you have to say conda activate my environment, because my env was created earlier. You can look at the videos earlier, and you can simply run now the file Python 3 and the file name. So weather forecast, this is the file name. So anyway, Linux is case sensitive, so you have to be careful about the file names. So now it's running. Python is slower compared to C++. So if you do CUDA programming using C++, it is much more efficient. So now you're running this. It is taking quite a lot of time compared to C++. So trying to break this program, because somehow it is taking more time. So maybe there is mistake in what we're doing. So if you press Python tab, if you press, it should come. Yeah, this is what it is. The file name, exact file name. There were some mistakes. Now it is usually takes time actually. So let's wait and watch. So in order to understand the Conda environment, etc., see that actually this is actually the data which is being read from the weather forecast model dot weather forecast site, actually open weather forecast, and from there it has read the online data. Now it's online itself is creating a neural network. The training is complete now. It has done a training a large number of epochs, then it started predicting. It's going on predicting. with respect to it created a model from the data. So, theoretically you must be able to take in new data according to the trends and patterns. It will go on predicting the next, let's say, few minutes of data or few hours of data, whatever, depending on the time stamp. Okay, then thank you.